Hello everyone! Welcome muli dito sa ating series of discussion about statics of rigid bodies. Ang magiging topic naman natin ngayon ay ukol sa moment effect of force upon a body. From its definition, magnitude, direction, where focus of discussion shall be on the analysis of moment using vectorial approach. In the later part of this discussion, a sample problem is presented para lalo nating maunawaan ang konsepto ng moment. Guys, lagi nyo sana ako samahan dito sa pamamagitan ng pag-subscribe sa channel nito at pag-click sa notification buttons para lagi tayong ma-inform every time na mayroon tayong bagong uploads ukol sa topic na ito. Magsimula tayo guys sa definition ng moment. Ano bang moment of a force? Sabi nga, aside from the tendency to move a body in the direction of the applied load, a force can also create tendency to rotate a body about an axis which is neither parallel nor intersecting with the direction of the applied load. This rotational tendency is known as the moment of the force. Sometimes they are also referred to as a torque. Magbigay tayo ng isang halimbawa. Tingnan natin ito nasa illustration na ito. Okay, so in the illustration we have a pipe which will be rotated by a wrench. Now if a force F sub m is applied perpendicular to the handle of the wrench at distance d. Imagine natin that we have here F sub m, ano? And this will be applied at a distance d and perpendicular to it. Thus, this will cause a tendency of the pipe to rotate about the vertical axis whose magnitude will be depending on the magnitude of F sub m and that of d. It will be rotating about its vertical axis, which is perpendicular to the plane containing the magnitude of the force. So let us look at this illustration. What will happen? Okay. Okay. Nakita ninyo kung ano yung nangyari, ano? So the tendency of the pipe to rotate is caused by the applied load P on the wrench at a distance d from the action of axis of rotation. So how do we analyze the moment of a force? There are two ways of doing it. One is that we can have it analyzed using a Descaler approach, and this is mostly used in the analysis of a planar force system. Kapag ang ating force system ay nasa plane lamang, madali nang gamitin itong scalar approach na ito. Now, how do we compute for the magnitude of the moment? The magnitude of the moment, or the tendency of the body to rotate caused by the force about a perpendicular axis to the plane, is proportional both to the magnitude of the force and to the moment arm d. So, this is the formula that the moment is equal to the magnitude of F multiplied by the perpendicular distance d. Itong dalawa na ito na nakikita natin sa ating illustration. Now, how do we determine the axis of rotation? According to the discussion, the axis of rotation of moment is the axis that is perpendicular to the plane containing the force. And so you are seeing here, this axis being perpendicular to the plane containing the force, this will be our axis of rotation. So that if we do have here, a force lying on the xz plane. Halimbawa, sabihin natin yung force ay nadoon sa xz plane, okay? Then the axis of rotation is the y-axis or an axis parallel to it. So let us show it here in the illustration. Imagine natin that we have here our xy and plane xyz axis. na kung saan itong plane ito tinatawag nating XZ plane. Halimbawa, on this plane, there lies an F having a magnitude of Kf sub m. Now, if we would like to determine what is the axis of rotation of this F, and when we selected the origin as the axis, then the axis of rotation shall be the y-axis. At kung pumili tayo ng other point, say for example, we selected this point on the plane, then the axis of rotation shall be the axis that is parallel to the y-axis. And so the body will be rotating in this direction. Now, suppose that the force lies on the yz plane. Therefore, the axis of rotation of the force in the yz plane is the x-axis, or an axis parallel to it. So, imagine natin that here is our yz plane, and on this plane there is a force that is acting on the plane. If we selected this point as our point where moment is to be determined, then the axis of rotation shall be directed along the positive x-axis. So kung pipili naman tayo ng another point somewhere here, then the axis of rotation shall be an axis parallel to the x-axis. It will be rotating in this direction. And suppose we have selected an xy plane. The direction of the axis of rotation of the force in the xy plane is the axis, or is the z-axis, or an axis parallel to it. So let us imagine that we have here the xy plane, and we have here a force whose magnitude is F. Then the axis of rotation of that F shall be, if we will be selecting this point as our axis of rotation, then it will be rotating about this direction. Or if we will be selecting another point somewhere here, then the direction of the axis shall be an axis parallel to the z-axis. Okay? So how do we compute for the analysis of the force, the magnitude? So if we are to use the vectorial approach, which is normally used and best used kapag ang ating force system ay in a 3-dimension or a force system in space. Okay, let us go back to this illustration and let us try to imagine that we have this representation of the force that is acting acting on a wrench whose tendency is to rotate the pipe about O. Mula sa definition ng moment, that moment is equal to the magnitude of F sub m multiplied by d. It is actually the product of this magnitude and that of the distance d. Now, let us say for example that we shall be considering a point A, which shall be located along the direction of F sub m, along this direction. Kunwari meron tayo ditong A that lies along this direction, somewhere here, and let us try to imagine that we have here this point A. This point A would have a position vector from O defined by this position vector, and let us call that position vector be called R sub A. Its magnitude shall be called as R sub A sub m. That magnitude shall be called as the distance from O to A. Then the angle theta that this position vector will be making with respect to this direction of the line shall be equal to theta. The distance d is the distance from the axis of rotation to the point where F is applied, and so this is the distance d, which is perpendicular to the plane or to the force or to the direction of the force F sub m. And let us imagine that that point be called as C. Now, from this figure, we can see the triangle AOC. Do you see this triangle AOC? That triangle is a right triangle. And therefore, from the triangle, we can compute for the distance D, representing the moment arm. The moment arm OC can be taken as the product of RAM multiplied by sine of theta. If this RAM sine of theta, which is equal to D, will be substituted in the formula for the moment, in this formula. Therefore, the moment becomes equal to what? Equal to Fm RAM sine of theta. So I would like you to look at this formula that resulted from the substitution of D by the magnitude of RAM sine of theta. You will notice that this formula is exactly the definition of the cross product of F and R, and this will maybe written as the moment equal to RA cross F. Therefore, from that formula that we have, we can make a generalization about the definition of moment using the vectorial approach, and that is the moment of a force about a point is the cross product between the position vector R and the force expressed as a vector, where R is the position vector of any point along the direction of the force from the axis of moment. So to explain it, let us go back to this illustration. Okay, when we say position vector, it could be any point along the direction of the F sub m. Say for example, we have here point A, therefore the moment shall be RA cross F. But if we wanted to select additional point, another point, say for example we have here point B, therefore this B would have a position vector from O, which will be defined by this R sub B. Hence, by the generalization, we can say also that the moment shall be equal to R sub B cross F. Even if we selected another point, say for example we selected another point here and we call that point as point E, then that E would have a position vector from O, which shall be called as R sub E. Hence, the moment will also be defined as the cross product of R sub E cross F. Or even if we have another point here, if that point shall be called as G, therefore the moment shall be called as RG cross F. Now the question is, how do we determine the direction of the axis of moment? Paano ba kinukuha yung axis of moment? So the axis of moment is directed in the same direction as the direction of the cross product R cross F. Yung daw direction ng moment dito ay sharing direction ng cross product between R and F, where R, as I have mentioned again, is the cross product or is the position vector of any point along the direction of the vector referred from the axis of rotation. Therefore, we can say that N shall be equal to the cross product R cross F divided by the magnitude of that R cross F. And so, you may be asking, why is it that the moment is written with the position vector coming first instead of the vector F? You will notice that in the definition of the moment here, the moment are all represented with the position vector all coming first before F. Why is it not F comes first? So this will be explained by this concept. The sense of or direction of movement depends on the directions in which F tends to rotate the body. So yun daw sense ng direction ng movement ay depende sa kung paano ang direction ng force when they act upon the body. And so it will tend to rotate the body. And the rotation of the body or the sense of the body follows the right hand thumb rule. So yung tinatawag nating right hand thumb rule. How do we apply this right hand thumb rule? We represent the moment of the force about O as a vector pointing in the direction of the thumb. Ito daw ay nire-represent being a vector na kung saan ang direction ng moment is directed by the thumb, is pointed by our thumb. With the fingers curled in the direction of the rotational tendency, na kung saan yung rotation ng moment is shown by how our fingers are curled against that axis. And so, to show that, let us imagine again that we have here our three mutually perpendicular axes such that we have here our x, our y, and our z. If we are to apply the right hand thumb principle, okay, then the moment the moment of the force shall be taken as the positive when it follows in this direction, considering the right hand thumb principle. Kaya nakita nyo yung direction ng moment. O kaya naman, kung y-axis ang tinutukoy natin, then the moment will be directed in that direction. Or if we are talking of the z-axis, then it will be directed in that direction. Or even if it is directed in any direction, say for example, it is directed in any direction, not the x, not the y, and not the z-axis. It is directed along that direction, and how are we going to determine the sense of the moment? The moment will have this direction using the right hand thumb principle. Or even if we have this direction, then it will be directed in that direction. So anong ibig sabihin nito? Ang ibig sabihin yan, ang direction na yan is treated as the positive moment effect of force about an axis. Yan daw yung tinatawag natin positive moment effect of the force about an axis. And this direction is produced kapag ang ginamit nating position ng cross product ay R cross F. Kaya yung ating representation ng moment, the position vector comes first because it will be producing moment following the right hand thumb concept or principle. Okay? Guys, ngayon ay subukan naman natin itong sample problem na ito para lalo nating mas maintindihan kung paano mag-solve ng moment of a force. Itong problem. What moment is produced by force having a magnitude of 240 Newton and directed from A at 2, -1, and 0 towards B at -2, 3, and -2 about point C at 0, 1, and 5. Find also the direction of the axis of moment having unit of measurement in meter. So in order for us to be able to understand the situation, it would be good to consider plotting the points on space so that at least we may understand how is the force directed and where are the points involved in the problem. And so let us imagine here that we have our space with this as our origin. Here is the direction of the x-axis, and this is the direction of the y-axis, while this one is the direction of the z-axis. The point A, having a coordinate of 2, -1, and 0, can be plotted on the space having two units moving towards the positive direction of the x-axis and one towards the negative direction of the y-axis. At the end of that point indicates the position of point A at 2, -1, and 0. While this point B at -2, 3, and -2 can be plotted by moving 2 towards the negative x-axis, 3 towards the positive x-axis, and 2 again towards the negative z-axis, and at the end of that point indicates the position of B having a coordinate of -2, 3, and -2. And according to the problem, there is a force F that is directed from A to B, this direction, this force, having a magnitude of 240 Newton. The point C, as indicated here, having a coordinate of 0, 1, and 5, could be plotted by moving 1 towards the positive y-axis and 5 towards the positive z-axis. And the end of that point indicates the position of point C at 0, 1, and -5. So the moment taken as the product of the position vector cross F, the question is, which position vector are we referring to in this problem? So it could be the position vector of any point, so that any point, since F is directed from A towards B, therefore we can use the position vector of point A from C, which is called as RCA, whose value shall be the difference of the coordinates of point A and the coordinates of point B, such that we have 2 - 0i plus -1 - 1j plus 0 minus 5k. That gives us a position vector equal to 2i minus 2j minus 5k. Similarly, we can also use the other position vector of the force where it is directed. We can use the position vector of B from C, this point B from C. So that the value should be the coordinates of point B minus the coordinate of point C, and that will give us a value of negative 2 minus 0, plus 3 minus 1 minus 2 minus negative 5, and that is equal to 2i plus 2j minus 7k. Similarly, we can solve for the vector f as a Cartesian vector, and we understand that f is equal to the magnitude of the force multiplied by the direction of the force, where the direction of the force can be taken as the coordinates of the points between B and A divided by the distance between them, and that is 2, this one, negative 2 minus 2i plus 3 minus negative 1 of j plus negative 2 minus 0 of k divided by the square root of negative 4 plus negative 4 square plus 4 square plus negative 2 square. That gives us the direction of f equal to negative 4i plus 4j minus 2k over 6. This can be simplified further by dividing both the numerator and denominator by 2, and that gives us a value of negative 2i plus 2j minus k divided by 3. So that if this will be substituted in the formula for the vector, that is f sub m, multiplied by n of f. Therefore, f shall be equal to 240 times the quantity negative 2i plus 2j minus k divided by 3, from which 240 will cancel, so that this gives us a simplified form of the vector f equal to 80 times the quantity negative 2i plus 2j minus k. Solving now for the moment by substituting the position vector RCB and R and F. Therefore, this becomes negative 2i plus 2j minus 7k cross 80 times negative 2i plus 2j minus k. So we'll be using the third order determinant, so that m can now be computed using the determinants of, again, the first element of the cross product will become the first row of the determinant, while the second element of the cross product will be the second row of the determinant, while the third row is equal to I, j, and k. So I took here 80 because that is constant. So that we use the extended form of the determinant by extending the first two columns, such that we shall have here the expanded form of the determinant. And so this can be simplified by taking first the product for I, so that we have here k2 minus negative times negative I, negative 1 will be negative 2, minus the product of 2 and negative 7, and that is equal to positive 14 multiplied by I. For j, we have the product of 7 and 2, that is 14, minus the product of negative 1 and negative 2, and that is equal to negative 2 of j. And for k, we have the product of negative 2 and 2, minus the product of negative 2 and 2, which is also equal to 4. That will be, for k. So that when this will be simplified, the moment will become 80 multiplied by the result of this one, that becomes 12i. The result of this one, which is also equal to 12j, and this will become equal to 0k. So that we can now solve for the magnitude of the moment by taking the square root of the square of each of the component, and that is equal to 80 times the square root of 12 square, representing this much, this magnitude, plus 12 square for this one, plus 0 square for this one. And so you shall have here the magnitude of the moment equal to 80 times the square root of 288. Or when we simplify, that is equivalent to 1357.645 in Newton meter. Now we'll be solving also for the direction of the moment of axis of moment, which we can solve for the direction of the vector of the cross product, because we know that the direction of the axis of moment is the same direction as the direction of the cross product of the position vector and the vector f. And therefore, it is equal to this numerator is equal to the the moment as a vector that comes from this magnitude, that is 80 times the square root of 80 times 12i plus 12j plus 0k is actually the representation of the moment as a vector, and this denominator is the magnitude of the moment, which is equal to 80 times the square root of 288. You'll notice that I have not simplified this one because later on 80 and 80 will just cancel each other. So that n becomes equal to 12i plus 12j plus 0k over the square root of 288. And from here, we can compute for the direction of the axis of rotation, how much angle does this axis making with respect to an axis parallel to x, an axis parallel to y, and an axis parallel to z, and that is equal to theta sub x shall be equal to arc cosine of 12 over the square root of 288. Alin itong 12 over the square root of 288? Ito yung dalawa na ito. The x component of the moment divided by the magnitude of the moment, and that gives us the arc cosine. And when we simplify that, that gives us a value equal to 45 degrees. Similarly, for the theta sub y, which is the magnitude of this 12 and the square root of 288, that is equal to arc cosine of 12 over the square root of 288. When simplified, that gives us a value of 45 degrees. While for the theta sub z, this is for 0. So that cosine or arc cosine of 0 over the square root of 288 gives us a value of 90. So to illustrate how it is directed, how the axis of rotation is directed, so let us imagine that at point C we draw the axis. That axis must be perpendicular to the plane containing O and points A and B. And so the angle 45 degrees that this is making with respect to the x-axis is represented by this angle. That angle that is being shown here is equal to 45 degrees. Whereas the angle theta sub y is the angle that that direction is making with respect to the axis parallel to the y-axis, and this is the magnitude equal to 45 degrees. While this theta sub z is the angle that this direction of the rotation will be making with respect to the z-axis, and that is represented by this direction. This angle now is what we mean 90 degrees. And so we expect that this force F will be causing a rotation about this direction in this rotation. It will be rotating in that direction. So I hope, guys, that you are able to understand and to follow how to apply this process in dealing or in computing for the magnitudes of the moment as well as the direction of the moments expressed either in terms of their unit vector or in terms of its angle that this direction is making with respect to the x, to the y, and to the z-axis. Kaya sana, guys, ay nasundan ninyo yung process at sana wag niyo akong iwan. Lagi niyo akong samahan sa ating tinatalakay na topic nito about the statics of rigid bodies. Kaya muli ko kayong inimbitahan na i-subscribe itong channel ko at you press also or you click the notification bell so that in my next upload you will be notified. Once again, thank you very much for listening.